In this video, we are going to study the mechanism of free radical substitution of an alkane using ethene as an example. So just now I mentioned that alkanes undergo, besides combustion, only free radical substitution. Okay, the substitution part, you can see that one hydrogen atom is substituted with a chlorine atom. What about the free radicals part? What does free radicals mean? Okay, and why is it that we need free radicals? Okay, so we need to understand this. Okay, so let's take a look at the 3 steps of a free radical substitution: initiation and propagation and termination. Because of the video size limits, I might only be able to cover one step at a time in each video. Let's look at the first step, initiation. We need to start the reaction. Remember, alkanes are extremely unreactive. They are non-polar. So therefore, they do not react easily. You need something to start it. And what are they? They are radicals. Radicals are extremely reactive species with an unpaired electron. So in the initiation step, we want to kickstart entire free radical substitution by generating radicals. Okay, how do we generate the radicals? Using UV light. Okay, so we use UV light or we use sunlight. We absorb, it could be light energy. UV is also a kind of light. Okay, so basically we absorb light energy to do what? To break a bond. Okay, so we break the Cl-Cl bond here. Okay, let me just recap with you what is the meaning of homolytic fission. Fission means bond breaking. Okay, what is the meaning of homolytic? There are 2 types of bond breaking. Okay, one is homolytic, one is heterolytic. Okay, lytic simply means break. Okay, so we are trying to break a bond. What about the word homo? Homo means same. The bond breaks in such a way that each atom gets the same number of electrons. So let's use an example, a generic example, AB bond. Okay, so if I talk about the AB bond breaks homolytically, it just means that the bond breaks in such a way that each atom gets exactly 1 electron. So after bond breaking, A gets 1 electron, B also gets 1 electron. What is this arrow that I drew that looks like a fish hook? Arrows in organic chemistry represent the movement of electrons. So this fish hook is a half arrow. It represents the movement of 1 electron. Please take note now. Half an arrow represents the movement of 1 electron. A full arrow represents a movement of 2 electrons. Okay, so we are concerned with homolytic bond breaking. I repeat, it just means that the bond breaks such that each atom gets the same number of electron, which is 1. Okay, so when AB bond breaks, each atom gets only 1 electron. Okay, so when the Cl-Cl bond breaks, okay, I use the half arrow to represent that this 1 electron goes to this left hand side chlorine, another electron goes to this right hand side chlorine. By absorbing UV light, to break a bond, we need to absorb energy, and then we get this chlorine dot. This represents a free radical. The dot actually represents the radical. What is a radical? It is a species with at least 1 unpaired electron. Okay, so imagine when the Cl-Cl bond breaks. Okay, the bond breaks homolytically such that each chlorine atom gets only 1 electron. Okay, each atom only gets 1 electron. Okay, to make things simple, we just represent the 2 electrons with dots. Okay, so we write 2 Cl dot. We don't have to write a Cl dot and a Cl cross. Okay, so this is not chemical bonding. We're not so fussy that it must be dot and cross for adjacent atoms. Okay, dot and cross to represent electrons for adjacent atoms. Okay, so this is fine. So this will be the initiation part. Okay, please turn to the next video for the propagation.